All right, this is Mayo. In this video, I will show you how to build an AI PDF chatbot agent that can decide what to do based on the documents you upload to it. So let's say in this case with Tesla's 10K, we've got over 100 pages in the PDF, tables, different sections. There's a lot going on. And so ultimately we want to have something like this where it's a chatbot. You can ask a specific question and then the chatbot is able to retrieve the relevant information to answer the question from where we stored the documents. And you can see it's picked up on what the document is. We can copy it. We can also see the different sources and the pages. And if I come here, where are the key risk factors, control paste, then it's going to go retrieve that as well. So if you've watched my video 2-3 years ago, GPT-4 PDF chatbot, this is kind of a more modern update of that. And where this utilizes LangGraph. So LangGraph is an orchestration framework by LangChain that makes it easier to build agents. So the difference between just a plain PDF chatbot and what we're doing here is we're given the model choice. So if I ask a question that's unrelated to the document that I have, so what is music, you're going to see that the model is going to be able to infer that the question is not related to the document and therefore answer the question directly. And this is very intentional. If I just quickly show what the architecture looks like, this is what it looks like using LangGraph Studio, which is a UI that helps you to orchestrate the agent. So you can see that I've designed it so that we check what the query type is, and if the query type is not related to the document that we have quote unquote ingested or stored. Again, concepts I've covered in previous videos, but for the sake of refreshing, we basically take the documents, convert them into number representations and store them somewhere called a vector store. So we check, and if the query type is not related to what we've stored, then we return the direct answer. And so you can see how we can expand on this to add other things. For example, I can add another branch where we can give the agent the option to search the web for certain types of information. Maybe if the user asks a question that by nature has recency in the question, we can extend this to do that as well. So this is the UI for one of the keystone projects for the book that recently released called Learning LangChain, which I did with myself, Nuno Campos, who's a founding engineer in LangChain. And so this will kind of give you, all the background information, the fundamentals. I'll put the link in the description. You can check it out, buy on Amazon. You can even do free trial O'Reilly as well. So we cover basically the full details from beginner to kind of launching an AI LLM application powered by LangChain and LangGraph. But this is one of the outcomes. So essentially you will have your own agent that you can then spin off for your own use case. All right, so let's dive into the technicalities and just understand what's going on as well. So let me just jump back in here. So the first phase in this, we'd like to, let's actually start here. So this is the official repository where the PDF, the chatbot is right now. You can see I've made, I put all the code here. It's all open source, and I'm just going to walk through what's going on in this code. Again, links will be in the description. as per here. But essentially what we have is two phases, right? We have the back-end mechanics, which is powered by LangGraph, as I said here. And then we have the front-end UI, right? Which is why you can see all this stuff shown here. So that's essentially what I've explained here. The tech stack that was used, ingestion, which I briefly explained, is this process of taking the document. We effectively convert the document into number representations computers can understand, and then we store it in a special vector store. So let's start with the first phase, which is this ingestion, right? How do we take this PDF and store it in a number representation? So I'm going to go into backend, and basically we have in the sources, we have what's known as ingestion graphs, right? So let me just show you the UI version of this. Right. So all we have is a start node or a starting point, the action to do the injection, and then the end. This is kind of the visuals of what's going on. If I kind of jump back in, LangGraph, like I said, it's an orchestration framework. It's very granular, so it helps you to control each step of the agent is going to take. So essentially what all this function is doing is it's going to essentially decide what vector store to use based on your configurations, and then it's going to add the documents to the vector store. So effectively it's going to the best way to explain it is convert them into what looks like this. So you're gonna each chunk, if you want to say, you're going to split your document into chunks, and each of them is going to have some sort of page content and some sort of metadata associated with that. This is kind of more of what's happening under the hood. And let me show you the retrievers that we're using. So in this file, the default retriever we're using is Supabase. So Supabase is a database, but also they provide the ability to store embeddings, which are these number representations of your documents. And Supabase is the default used in this example. Now, obviously, if you want to add your own retrievers, you can just come here and also add them. But by default, we use Supabase. And so what happens is, you can see here we first initialize the OpenAI embeddings, we create the Supabase client, and then we use the LangChain's Supabase vector store, which under the hood, as I said, is going to convert the different parts of your document into embeddings and then store them in the chosen tables. So let's go back. So that's mostly what all of this is doing. It's kind of going in, creating this these document objects, storing them in the vector store, and preparing them for you to be able to retrieve or to fetch based on the user's query. There is a little pre-step which is in the README. So if you're going to use something like Supabase, which is here, so I'll just show you my PDF. So this is what I ended up with. But let me show you the step before that. So they provide an SQL editor. So what you do essentially is you go grab the full instructions from LangChain to create the table. So just to quickly, a brief overview of what's going on here. This is the table. These are the properties of the table. So content metadata, as I showed you earlier, the dimensions, which is for OpenAI. So if you do change to another embeddings provider, you would change the dimensions according to what they require. Here it just allows you to work with embeddings. And then here's the function that's going to be called to later on for matching. So when you send a query from a user, it's going to embed the query, again, convert to numbers so that you can compare the numbers of the user's question to the retrieved, the what's been stored that has similarity to that. So all of this, basically you copy into the SQL editor, you paste it, and then you run. And then once you've done that, Supabase would store, it's got a database here. It will have functions. You will see the match documents function. So if I just go here, and then let's go back. And then you'll see a new table as well. So this is the documents table. You can see the ID, the content, the metadata, and the embedding. So this is all done before quote unquote ingestion. And it's good, you can see, just so you can visualize what I'm talking about here, that essentially what we have is embeddings, the metadata, the content, and the ID. Remember, I said the embeddings are number representations of your, your text effectively. And what we've done here is split into different chunks based on the page number. So this is page 77, 75, 74, and each of them we get the embeddings and then we store it in this table. That's what this whole, what this is helping to do, essentially, where we passing, let's go to the graph. So you can see this is the graph that you're seeing the visuals of here. So start is represented by this, what they call an edge. So an edge is just effectively pointing to going from one place to another. So we're saying we're going to go from start to ingest docs, which we defined up here. And we are going from ingest docs to end. So that's exactly what we can see here. Start, ingest docs to end. And you can see that this takes in your docs. So you're the one who's going to provide the documents that you want to be quote unquote ingested into your vector store. So if I go back here for a second, you can see the UI even provides a way for you to see what to even add if you want to test how this is all going to work. And the reason why it's been left this way, as opposed to me saying, hey, here's a particular way to split your documents or kind of structure it, is because you might want to do it in a different way. You might have a different source of data. You might not want to use a PDF. So this gives flexibility for you to do that. I believe, yeah. So this is an example of what, when you use one of LangChain's loaders, right? A LangChain loader is effectively a way to take any source of data. So this can be a PDF, CSV. You can see they've got tons of options here. You also got web loaders, different providers. And effectively, we just convert them into this kind of structure I spoke about, where you have the page content, the metadata, and that's essentially what the loader does. And it creates a JSON file, which you can then pass into any vector store. So we use the Supabase now, but there's many other options: MongoDB, Pinecone. Some you can even use in-memory vector stores as well. So this is just a sample of you can see source, the PDF, and then you can see the page number as well. That's extracted. So for this one, I use the PDF loader, and that was done ahead of time. So let me show you. Here, this is just a demo, right? Just so you have an idea of the logic. So we have the PDF loader, the PDF path, we load, and then we have effectively a way to split the document into chunks so that we can have different rows. You can see here, all in different rows. And this is useful so that you don't effectively overuse the context window of a model. Because typically what would happen is that most models can only take, 100,000 tokens, 200,000 tokens. So this just helps to manage the size. And all this logic is doing is splitting your documents and then kind of preparing them in the structure I showed you previously before you do the ingestion, as we discussed. Okay, so this is effectively what's going on here. Now, in terms of structure of the backend, LangGraph is very particular about how you structure the backend so that it can expose an API for you to use for local development. So the first thing you want to do is make sure you have this file, langgraph.json, and it has to be defined in the way I'm showing you right now. This is obviously a JavaScript example, but their docs have more for Python if you want to use that. So there's two things you want to do. First, define your graphs. So you can see here, these are the name of the graphs, and then I point to where the graph is coming from in the files. You define what your environment variables are, and then dependencies is referring to here. So the package.json is the dependencies used for the agent. And so you can see when I go to Studio, and I'll show you how to spin this up in a second, you can see the name ingestion graph corresponds to what I defined here. And then this is pointing to the ingestion graph, which is here. So we have to define it in a certain way. Again, all of this is covered in the book. If you want to check that out. And we export the graph, compile it, and then we can also give it a run name. I'll go into how you can use the run name to even go deeper into seeing what's going on. So this is essentially the configuration for the ingestion. And when we're dealing with so I'll show this briefly as well. So these are the environment variables, which covers the Supabase URL. Again, all the instructions are on the README and how you can get this information from the settings. But again, if you want to use a different vector store, you would just tweak the backend accordingly. Langsmith tracing, which is in here. I'll show you that in a second. And then the API key of LangChain, and then the project name. All of these you can get from Langsmith, which is they've got a free plan you can use and just get the API keys, which will allow you to start to see all this visual representation of your graph. Okay, so let's go to the retriever. So once you've kind of completed this ingestion phase, what will happen is your vector store will be populated with all of this stuff. So now you've got ID, the relevant content, the metadata, and the embeddings. So the idea now at this point is when a user asks a question, like I did here, we're going to first check, is this question related to the documents we have stored? If it is, then we will first convert the question into number representations like this. And then we will check all of them to see which one of these rows have numbers or floating point or vectors that are most similar to the user's question. Based on that, we're going to retrieve the relevant chunks of documents, take that, and then give it to the model to help it answer the question. So let me try and explain this very quickly again, if you haven't seen my previous videos. So let's say here, oops. Okay, so user asks a question, so user question, and then what will happen is we will have here convert to embeddings, which are the number representations. So user asks a question, convert to embeddings. You have this store. So we already have this right, vector store docs embeddings. So we have this place that already has the number representations of your documents. So we're going to go from here to here. And then once we convert to embeddings, we're going to go here. And we're going to effectively perform what's known as a similarity search, where we're just checking, or let me just make one check for similar embeddings. Let me just make it more simple to understand. So user question, convert to embeddings. Now we go to the vector store to check for similar embeddings. And then what we're going to get back is a bunch of, let's do this color. So we're just going to get a bunch of relevant chunks, right? So these are all going to be, depending on how you split your source, we're going to have these different relevant chunks, right? These are all relevant to answering the question. Then we're going to take these, let's say this is the AI model. So we're going to call this the AI model. So this is the large language model. And then let's call this the context for answering the question. So usually they have a context window, right? Or in other words, it's just after you ask your question, you can give the model extra stuff. You can do this with ChatGPT or anywhere else. So this is the model. think of this more like the the chat box, or the where you can put in the text if you were using a UI, except that we will just say, hey, answer the question based on what's below, and then you can copy and paste your context. And so what we're gonna do now is take all of this, and then we're gonna put it in here, and I'm gonna call this relevant context. Once we have that relevant context, we will then be able to generate. So we have the question, and in the end, we're going to have an answer to the user's question. Okay. So answer. So that is essentially the flow, where we start with the user's question, we convert to embeddings, which are number representations of the user's question. We search the vector store for other number representations that are similar. We pull out the relevant chunks. We pass that to context to the model, so the model can see all the relevant chunks and then answer the question based on that. That is essentially all that's happening here. These are the relevant chunks. This is the question, and this is the answer. The model is given based on all the chunks of content it saw here. So it's going to see maybe all this content here, or all this content here, maybe 4 or 5 of them, and all of them will just be passed to the model, and then the question will be at the top. So you would have the question, and then you would have the context, which would be all the relevant chunks retrieved, and then we will be able to answer the question. So that's effectively what's going on here, where we're having this. You can control most of these. You can control what embeddings model you use. You can control what vector store you store the embeddings. You can control how many chunks you pull back, or how you create the chunks. You can control the model. You can control the prompt and what to pull out from the context. And you can even control how to return the answer. How long should it be? What format should it be? So there's a lot of control in all these different components here. And this entire process is known as retrieval, i.e., how the process of retrieving relevant documents to help an LLM to answer a user's question. And that is essentially what this workflow is, except that in the traditional sense, or in previous videos or ways that chatbots are typically covered in the past, it would just be start, retrieve documents, generate response, end. In this case, it's different. Where agency comes in is here. The fact that it can decide what direction to go to based on the user's question is what makes this agentic. And that is handled in the graph. So I'm going to walk into the graph for a second. And again, like I said, a lot of this, if this is all new to you, you can look at the LangGraph docs, or like I said, I recommend purchasing the book so you can get a step-by-step guide helping you through the key things you need to know. So what we have is this function that checks the query type, and we are going to effectively send it off to the model with a prompt. And the prompt is essentially more or less telling the model to determine if the question is retrieval based or not. So if we go back, we ask the model, and then the model returns a answer to us on what route to take. So if we go down to the construction of the graph, you can see we start here, as I said, with the checking of the query type. LangGraph also provides what's known as conditional edges. It's just basically a way to give you the option to break out like this. So all we're saying here is, after we check the query type, based on the results, we are either going to go to retrieve docs or direct answer. That's what this is doing here. And then we have edges from retrieve docs to generate response to end, or direct answer to end, which we can see direct answer to end, or retrieve docs, generate response, or end. Now, after we've checked the query type, let's say we go down this path, right? So now we're going to go retrieve the documents, and we can see we've defined the node for retrieve documents here. And what this is going to do in our case is going to go into Supabase. Remember, Supabase is the default, but you can always change this. And it's going to answer the question based on that. So we're going to again answer to the question. No, it's going to retrieve the relevant docs first. And then it's going to move to the next node, which is generate response. And what we do here is we take the context, which is the retrieve docs. As I said here, these are the retrieve docs. And it's going to effectively send it to the model with the question, right? And the model is going to use all of this to provide a final answer to the question. So this is what the prompt looks like that is sent to the model. You're an assistant for question answering. Use the following pieces of retrieve context to answer the question. So the user's question, in this case, what is this document about, is going to get passed in here. And the context, which is all the retrieve docs, is going to get passed in here. So this is the prompt that, we can kind of simulate using the ChatGPT UI or Anthropic or whatever you're using. We're just kind of doing this programmatically, right? So rather than go in here and copy it, look manually and see, okay, which of these are relevant to the question, and then copy them out and then paste it. We're doing it all programmatically. And effectively, by the end of that, we are able to generate a response. So one of the cool things with Studio is, before you even build out a UI, you can always just come in, and based on what you define in your state, the state is just effectively a snapshot of the properties that you've defined of your graph. So if I go here to state, I've defined, the query, the route, and these are effectively properties that will be shared throughout the lifespan of the graph. So at different points, you're going to see the state change. So let me give you an example. Let me come in here. If I say, what is this document about? We submit. You can see it's gone down the retrieval documents path and then generates the response and end. This is very useful for testing, debugging, before you kind of expose it to users or connect it to a front end. But let me just show you for a second. At each point, you can view the state. So you can see the state at this point, query, but the other route at this point is empty. Check route, the state of route is now retrieved, and then we move over to the next node, which is retrieve documents, which has retrieved these relevant chunks to answer the question from the vector store. And then we pass it to the model to answer the question. So if you open output, you can see the final state of all the properties you defined. You can see the JSON format of that. There's a lot more going on under the hood with LangGraph that allows for you to do more complex stuff. For example, if you wanted to add a human in the loop, you can stop the graph at any point and wait for someone in the UI to input. You can also track usage. So you can see other things like how much was used, were any tools called. This would be relevant if you wanted to add other things like web search or any other ability for the model to call other functions to retrieve data outside the data set. So obviously we could make this a lot more complicated, but this is more of a base template for you to get started. And at any given point in time, you can always rerun from a particular point. Say you wanted to test something specific, you can rerun and take it from there. Also, LangGraph has these things called threads. You can just think of threads as effectively a collection of these runs. You know, in a given thread, you're basically keeping track of all the back and forth going on between the AI and the user. And then if you create a new thread, then it kind of wipes out the memory. So you wouldn't be able to refer to something in the past. Let's say the user keeps asking questions and then they expect that the current conversation they have is still able to contextually understand the subsequent questions. You need to keep it in the same thread. And so this is important. And then if you want to give the user the ability to kind of clear the memory and start from scratch, you just create a new thread and now they can run from that. So this is typically what you would see with chatbots. If here we had a sidebar, we had different names for the different chat conversations. Each of them, you can kind of think of them as a thread, effectively. And then within each thread, you have a state, right? Like I said, which is just a snapshot of where your properties are at based on the different nodes that have been run. You can always come in here, rerun, tweak, test. You can even manage configurations, which you set. So for example, one of the configurations that you might want to tweak is the query model. So here you can see we're using OpenAI GPT-4.0 by default, but you might want to provide your own model. Obviously, you know, from a programmatic point of view, you would need to deal with it this way, but I'm just showing the UI version. You would come in here and put in, you know, whatever, Anthropic or whatever other model you want to use. Obviously, bear in mind that you need to make sure you have the appropriate, you know, API keys stored and so on. Retriever model as well. And then these might be relevant to you in terms of, so let me go to the configurations for the retriever. Okay, so we have these other properties called and K. Okay, filter key arguments and K. Okay, what's going on here? Okay, so K is just the number of documents to retrieve. So in this case, 3 is K. So we've retrieved 3 chunks. In my UI, I'm retrieving 5. So you can see default K is 5. So K is how many relevant chunks to retrieve. So you can provide that. You can change that yourself through the back end, through the front end, which I'll show you in a second. So K is just how many relevant chunks to retrieve of the documents to answer the question. This is a subjective thing. It requires testing. There's pros and cons, right? The more documents you retrieve, the more information the model has to answer, but you also risk retrieving irrelevant information. There is a risk that some of these might contain content that is not relevant to answering the question. So that's the problem. And that can cause hallucination. On the flip side, less sources means a higher risk that the model is not able to answer the question. So this is typically something you would have to test and see what works for your data set, alongside obviously what chunk size should each chunk be, right? So if you're going to split your document into chunks, you need to experiment as well. But for default, I usually start with 5. And you can tweak from there. Filter keyword arguments here is just helping you to effectively filter your metadata. So for example, in my case, my metadata contains information like page number, UUID, source, file name, and so on. Now, if I wanted to, for example, want my model, want the retriever to only fetch based on a specific file name, then I can begin to provide, other things like the keyword arguments. So where you see this being used is here. You can see we have the make retriever. This is the configuration. And based on what's passed in here, that's what's going to influence what the retriever is going to use. So if I pass in a particular file name and a particular K, then the retriever is going to use those values to retrieve in a more narrow set. So it just allows you to have more granular control over what you're retrieving. So this is the backend in a nutshell, where you have this set up. And once you clone this repository, where you just go here, you copy or however you want to do it, and you git clone this repository as per all the instructions here. You can just follow it to do that in the README. So once you've cloned this, you will have the full repository in your local development environment. And what you can do at this point is start the local server. So LangGraph allows you to basically spin up a local server, which is the studio we actually saw. So this is not live. This is the local development server that's been spinned up by LangGraph. So if I go back here, essentially that is all defined in the package.json. So we have this LangGraph dev script that will spin up the LangGraph development server. So I've already done that. You can see that it's running here. When you first spin it up, so let me show you what it looks like initially. You can see this out. So it would look like this. So it will give you an API, a localhost API, and then a Langsmith Studio base URL. And that is what we are able to start playing with here. So make sure you set your environment variables. You set this to true for tracing. I'll show you why that's important in a second. And then your API keys and the project and so on. Just the name of the project. So that once you spin this up, you will get the UI. So all you're doing is npm run LangGraph on colon dev, right? And that's going to spin it up for you. Okay, so backend is working. Okay, so now in terms of the front end is Next.js. I'm not going to spend too much here, but the key things to note about the front end is that we use the LangGraph SDK, which is just basically a wrapper of the different ways to interact with this API you've exposed, right? The backend API. And we have an API route. Now, this route is important on two ends. Okay, so what can we do, right? Remember, we talked about the ingestion process. So what we want to do is give the user the ability to upload their documents. So this is the route that handles the user's upload of the documents. So effectively from the UI, where we have run npm run dev, it spins up the UI. So here I'm using localhost 3001. So now we have the front end working and we have the back end working. So let's go back to the front end. So here we have this option. This just gives the user the ability to effectively select PDFs from their drive. And when the user uploads or selects the PDFs, we're going to go in here. I'm not going to do it because my vector store is already populated. But all this is doing is, if you pay attention, we are going to use, so we have this function here. We are going to use the client to connect with the API URL. Remember, the API URL at this point is the 2024 localhost. So all of these you would define, and again, this is all in the README, but this is the default API URL. Then you put your API key, an assistant ID. Remember, you define that in the back end. If I just go here, you define the name of each graph. So that's what the assistant ID is. Let's go here. So you've defined ingestion graph, retrieval graph, and then name of the project, essentially. So all we've done is create a client, through the front end's API route. We get the URL and we create the client. So now we have a way to connect with the LangGraph backend that you've created. This is the logic to handle the PDF using the PDF loader. So when we go back to this route, all we're doing is connecting to your backend, which is currently running, handle the files, validate them based on size. Again, you can tweak this however you want. Process the PDF into the page content metadata structure we discussed. Create a thread. We discussed the threads and how threads are just these IDs that represent a run or back and forth conversation. So this would be a thread, all these conversations here. And if I refresh, it would be a new thread. And then here we run the ingestion, right? All we're doing is invoking the ingestion graph that you defined in your backend, passing in configuration. So we're going to pass in the documents that are going to look like this. And then we are going to pass in configuration. The configuration is whatever you have defined in this file. So retriever provider is Supabase, and here's the other case5 and all of that. Remember, I said you can change these values or even give the user the option from the front end to change these values. So we're going to run, and then documents are going to be ingested. Now, like I said, I'm not going to do it here because otherwise I'm going to pollute my vector store. Okay, so now this is the chat route, and this is what you saw when I asked these questions and what it was able to do. And again, it's kind of the same thing. All we are doing is checking if there's a thread, again the retrieval ID, which is the retrieve graph, create the server client, and then we stream. So LangGraph provides the ability to effectively, rather than just get the response in terms of just the question and the answer, it allows you to see each step of the nodes and see what state they're in and what messages were generated. This is very useful not only for debugging but also showing the user different steps. It helps you to also get different types of data. So rather than just, hey, here's the question and then you just get the answer, programmatically you can see each step of each node and each value returned for the different properties. So that's essentially what I'm doing here. I'm trying to get different stream modes, which it provides. Again, all of this is covered in the book. All the details about how LangGraph works. And again, we're passing the configurations, the default configurations, and then here is just handling the streaming and all of that. And that's it in a nutshell, effectively. So we end up with this ability to ask questions, retrieve based on relevant sources, route if the user asks a question that is not relevant to the sources, and then you can just build on this. You can add web search, you can add API connections, you can do all kinds of other complex stuff. You can have the agent go in different routes, but this is a good foundational template as a starting point. Like I said, the full README is available here. I think we've covered most of this: the front end, the back end, local development, usage, and then deployment. If you want to deploy, you can follow the guides here. You can self-host. And so all that would happen is after you've done the deployment, you would essentially change the URL of the backend. So instead of using the localhost 2024, you would use the deployed version. So in LangGraph, you have the ability to, once you've got access to Langsmith, you can deploy. So it gives you playground, but you also have the platform. And in the platform, you can create a new deployment where you select the repository, the name, the branch, where your file is, and then you deploy. And once you do that, you will get a URL, and that URL you can then use to effectively connect to your front end, you can share with others, and so on. Effectively a backend API. Let me just go real quick into tracing and why the tracing is important. So you can see here PDF chatbot, which we named. I mentioned previously about the importance of why you want to have this tracing to true, the API key, and all of that. The reason why is because it allows you to use LangSmith for debugging and kind of seeing what's going on under the hood. So for example, let's look at the first question I asked. You can see now it's given me the name, so that's the retrieval graph, the number of tokens, how much it costs, the latency. I can go through each step inside LangGraph, inside the different LangChain functions used, and just see what was going on. You can see here at each point. At this point, the route is not yet defined. We don't have messages or documents, but query is defined. This was the chat prompt template that was used. So I can even look at essentially what's going on under the hood. It's very useful for debugging, testing, improvements, and so on and so forth. And so you can see here I get to look at all of this. I can add to a data set. Yeah, essentially it's very good for kind of debugging, seeing what's going on under the hood. You can see each thread, as I discussed to you earlier. We have different threads, and each thread we can see information about the thread. And what's pretty cool is, once you kind of have enough back and forth with the user, you can then create a data set. So let's go back here. So let me go into threads. Okay, this is just one trace. Let's get one that has 3 traces. And you can see all the different traces here. The back and forth, the turns. And then I can add this to a data set, right? So when you can add it to a data set, and when you have a data set, what's also cool about LangSmith is it allows you to perform evaluation. You can use all kinds of evaluations, conduct experiments, and essentially improve your entire process. So everything we've defined here can be improved. Even how you transform a user's question before it's embedded. So every component here can be improved. In the book, as I said, we cover everything. We cover evaluation. Here's a full table of contents. From the basics, LLMs, prompting, LangChain, the basics of LangChain, retrieval, which is what we just covered. Different strategies, query transformation, routing, construction. Talk about LangGraph, deployment, and even all the way down to testing and evaluation. So if you want a comprehensive overview of how to build your own AI agents, then I would recommend you check out the book. But this is more of a base template that most people who've read the book should be able to kind of build out themselves by the time they finish reading the book. But if you just want to use this base template to spin off in your own projects, then that can work as well. All right, cheers.